entire short career, about 10 years now. And I've actually developed a full DNP3 protocol stack, so I have a pretty good insight into kind of what things can go wrong when you're writing client and server code for these kind of systems. And so I actually wrote a security testing tool earlier in the year, around February, just for the purposes actually of testing a open source implementation of the stack. So I think that's kind of an interesting story that, you know, I'm not a security researcher. Chris isn't a security researcher. Chris is actually a PE at a major utility. And the tool wasn't written to go and do bug hunting. It was really just written to kind of harden and make sure that one particular implementation didn't have any bugs. But, you know, around April, after talking to Chris, kind of got interested in to see if there were any issues in other implementations. So the actual research was somewhat serendipitous. And we can go to the next slide. That's all right. I think what we found was pretty surprising to both of us. You know, we've tested things from about 20 different vendors so far, a little more, and we've had about a 95% vulnerability rate, and you know, we found some defects in 95% of the products tested. That was 100% until a couple weeks ago. I actually found something that I haven't been able to find a bug in. I'm definitely going to give that vendor some kudos at an upcoming conference. But you know, when you test 25 things and you hit a 95% rate like that, it starts to become systemic, statistical. 9 of those advisories have kind of popped out the other end of the ICS cert queue as public advisories, so you can kind of go and see what's going on with that. And I think it's important to say that, you know, there's really nothing wrong with the DNP3 specification specifically. You know, what we're seeing here is just a consequence of the fact that it's a big specification. You know, compared to something like Modbus, which is just very simple, it's huge. You know, the specification for Modbus is 60 pages. DNP3 is over 800. But, you know, I don't want to just pick on DNP3 for complexity. When you move to something like IEC 650, you've got a specification that's 1,800 pages. So I think, you know, my overall message to the industry as a software engineer is that, you know, bugs scale with the number of lines of code that you have, and when you move to more complex systems, you really have to demand a kind of different level of testing. But I do support the DNP user group and their message that there's, you know, there's nothing wrong with the specification. These are issues in implementation. Next slide. You know, we found a few things that are, I think, that are unique. You know, people have been kind of beating up on ICS equipment for a decade now. It's no secret that ICS software has a lot of bugs, and we all need to do better with testing. But, you know, one of the things that we did, I think, that was kind of unique was actually testing the master side of these connections. You know, in the broader IT space, we've known for a long time that, yeah, you can attack a web server, you know, send malformed inputs at a web server and maybe crash it. But we've also known that, you know, data coming back from the web server to your web browser, the client, can also be affected by, you know, malicious data. So if you rise up to sort of the 10,000-foot view of client-server architectures, this shouldn't come as a surprise, but nobody's really looked at the master side of connections. And when you think about it, there's a lot of risk there because masters are monitoring, you know, hundreds of substations potentially for larger investor-owned utilities. You know, and at a minimum, you crash these systems. Sometimes the bugs are things like infinite loops where the software becomes unresponsive. But because the software doesn't crash, operators may not see the values. They might not know that they've basically been disabled until someone notices the values are not refreshing. Then you have to go and, you know, manually reboot the front end and so forth. So, you know, we don't really know what the implications are going to be for this. But, you know, when you think about it, you can go into a remote substation in the middle of nowhere and compromise the master, or from pole-top equipment that has no physical security, things like capacitor banks or voltage regulators. So it's going to be interesting to see what the security community and the utility community kind of make of this kind of new attack vector that we're pointing out to them. And then the other aspect that I think this is important is that, you know, we found all these vulnerabilities by scanning the TCP side of the communication, the traditional networking, but we verified that the vulnerabilities also exist in serial. You know, DNP3 was originally designed for serial networks, for dial-up. The stuff gets used on 900 megahertz radio. So if you find a bug in IT and the product also supports serial, the same bug's going to be there. And that's currently completely outside of regulatory scope in terms of NERC set. So it's going to be interesting to see kind of what the community does with that as well. Next slide. I touched on this a little bit, kind of how we're doing this. We're using an automated tool called a fuzzer. And basically what it does is it has a full grammar of the protocol, so it understands the MP3. And it sends a mix of kind of malformed and valid messages, maybe with valid function codes of unexpected objects. And the software kind of chokes on those messages in various ways. We're not the only ones that kind of have this capability. This has been around for a while. You can go and buy boxes to do this kind of testing from companies like WorldTech and Mu. But until June of this year, nobody really had an offering to test the client side, the master side of these connections. And now there's one other company that does called Codenomicon. They have an offering that can test both. So I'm just pointing this out that there are multiple options for vendors to kind of either do this testing themselves with open source frameworks, or to buy something from one of the 4 existing vendors. So it really isn't something that terribly new. Next slide. I think what is new is what we're going to try to do is something a little bit different. Instead of trying to bottle up this knowledge, license the tools, and lock it down, we're actually going to release this stuff out in open source and try to form a community around improving these tools, try to get vendors interested in contributing to it. So that's going to release is going to happen in March at the SANS Data Summit, and there's a link there. And Chris, feel free to send this PDF out to everybody on the call and kind of go out and check what we're doing. I mean, in full disclosure, there is a business model around this. I'm going to charge vendors, depending on size, kind of early access to the tools. But it comes with full source code, and we're really trying to build a community around these tools instead of just selling the products. So, we also have a roadmap for other protocols, and we kind of want to build these things collaboratively with the people that understand the protocols. Because the way I see it, what we have is kind of a knowledge divide. We have the vendors who really understand the protocols and their systems, and then we have security providers that don't really understand them, don't have access to the source code to improve their security tools, but they really understand the security testing. So what I'm trying to do is kind of bring those 2 bodies of knowledge together into the community so we can produce something that's kind of better than the sum of its parts. I think that's it. I'd be happy to take some questions on any specifics.
Okay, and given the nature of this session, I'm going to end the recording now. So